step back for a moment before we dive into the nitty-gritty of design and modelling, to think about why we're here. There are many aspects of software engineering that we could have chosen to have a course about, and many aspects that we don't have courses about in this university. So why is it that we have chosen to have a course on design and modelling? Well, full disclosure, of course, partly it's because that's the area that I'm most interested in and I have some say in it. But that just moves the question, why is it that I'm interested in design and modelling? The answer to both of these questions is that after programming, they are arguably the most crucial skills for a software developer to have. Well, why is that? So you might ask yourself, well, is it because they are where the pain is felt in software engineering? Is it that everybody knows that design and modelling are the hardest things to get right in software engineering? Well, no, it's not that. The pain is not felt during design in software engineering processes. If you ask people where the pain comes, they will almost always, go try this to people who work in software, tell you that it's requirements, because errors with capturing the requirements are the cause of most problems with software, or it's maintenance, and one factoid with some support behind it is that maintenance of software, the cost of maintaining software after initial delivery, actually accounts for 90% of the cost of software ownership. So why aren't we having a course on requirements or maintenance instead? Why do we waste time teaching modelling and design, and indeed testing as well, which also isn't where the pain is felt? Well, let's look at it. So why are requirements hard and why is the pain felt there? It's basically because eliciting requirements for software is very, very hard. It's not a solved problem, even though we do have quite good techniques for managing requirements and handling this issue. It's hard because if you've got customers at all, they genuinely don't know what they want. It's really hard to have somebody go along and say, what could a software system do for you that would solve your problems or make your business more efficient? It's really, really hard to answer that question. And you may not even have customers yet. It may be that you would like to build a software system and then find customers once you can convince them that they would like your wonderful software system. Or even if these people exist, you may not get access to the right people. You might find yourself talking to the procurement manager when the people you really want to be talking to are the people who are going to do the data entry in your new system. You may not ask the right questions. And even if you can get past all of these issues and you get perfectly gathered the requirements for your software system as they are this week, requirements change all the time anyway, for all kinds of reasons. Okay, so there are lots of good techniques for handling some of these problems, but still you will get it wrong. Okay, so what do we do about the fact that requirements capture will be imperfect? Well, what we need to do is we need instead of reaching for the elusive state in which we capture the requirements perfectly and then they never ever change, which isn't going to happen, what we instead need to be able to do is to change the software quickly and without breaking it when the known requirements change. Okay, and that's where good modelling, design and testing are the things that let us do it. Okay, that's why this is valuable. Very similar story for maintenance. Okay, so evolving software over a long time is costly and it's often difficult. Why do you even have to? Well, partly because the requirements change, as I just said, and partly because the software itself rots. So you find that the software was built based on assumptions that turn out to be false. You find, it was built to work with a particular hardware or software component that ceases to exist, that turns out to have security problems or not to get security updates anymore, and so it has to be retired. All kinds of things change technically, as well as with the requirements. And also the people who develop the software move on. So somebody once understood why this piece of software was designed the way it is, but they're not here now, and it may not be so easy to work out how to change it in such a way as to maintain all the good properties that you want to maintain, whilst also making the change that is the reason why you're touching the software at all. And again, there are things you can do, but it will still be costly. And again, What we're talking about is the need to change the software quickly and without breaking it when things change, and again, it's good modelling, design and testing that lets you do that. We have an additional major challenge, by the way, for allowing those things to help us when it comes to maintenance, which is to say, it's all very well to have had a good model that helped you in the software development process. How do you manage to make sure that you don't lose those models once the software is actually delivered, and that they don't just kind of get out of date? And we'll talk about that more later as well. Slightly different topic. UML, for example, can be used in different styles, and it's important to understand this so that you can use it in a way that's appropriate to your needs, and perhaps even more vital, so that you can be clear with everybody else who's interacting with you and with your model what your intentions for your model are, and so that everybody's on the same page. So you might use UML very informally. So I said that people will always draw diagrams of some kind on napkins or whiteboards to clarify their thinking. If they happen to know UML, those will be UML diagrams, okay? But those diagrams drawn under those circumstances will be not really formal artifacts, at least not available to be used as formal artifacts. Sometimes people develop diagrams in order to put them in documents, and this can even happen after the code has been written. It is not quite so common these days to write design documents after delivering the software as it used to be in the bad old days of the software crisis, but it still happens. Or it may be that UML diagrams are actually important formal artifacts within the development itself, and that's going to happen when they are developed in tools, typically before the code, and then code is generated partly or completely from the UML diagrams themselves, okay, and automatically, in some sense, kept in sync with the diagrams, and this is an attempt to get more benefit out of the cost of modelling. And again, we'll see more about that in labs as we go through, and we'll talk about it. It turns out that UML is not really the ideal language to use in that kind of setting because of what I mentioned before, that it's an extremely complex language and not really all that precisely defined. In the required reading, I've asked you to read an article by Martin Fowler in which he describes UML being used as sketch, as blueprint and as programming language, and these three ways are very parallel to what I put in those 3 bullet points above. It's not absolutely identically what I've put there, and you should check your understanding of the Fowler reading by asking yourself, what do I mean by that? In what way are these 3 ways of using UML not precisely the same as the classification I just gave? So, to do before you go on, visit the course site on Learn and join the Piazza class. In this course there are many small bits of different kinds of work that you have to do. And if you're watching lectures in videos as instead of turning up physically to lectures, it's even more so. So do schedule time into your week for SDM work and establish yourself in an organised way to make sure that you know what you've done and what you haven't of the various things that you have to do. I hope that the information on Learn should help you to keep straight what it is that you have to do each week. Read through the lecture slides, ask, on Piazza, or ask me about anything you're unsure about. Establish a habit of visiting the Learn site every week to see what you have to do. And anytime there's a live session, please bring a writing implement and paper. Don't just rely on doing things on screen, because sometimes paper's just much faster and easier. Good. See you again shortly.